this is the point P dash with respect to the coordinate axis frame A, that equal to the rotational matrix A to the B, and then the position of that particular point in the coordinate axis B here. So here, if you know the rotational axis, then we can find out this one here. And this is the rotational axis that we have, a matrix that we have developed here. And what does it mean here? The frame B or the coordinate axis attached to the frame B is rotating with respect to the coordinate axis A through a arbitrary angle phi here. This is a phi and this is rotating through a arbitrary angle phi, and it is rotating about a arbitrary vector in this space. This is rotating about a arbitrary vector in this space. So how to find out rotation about this arbitrary vector in this space? Again, we don't know. This is similar to the our first case where if you want to find out the position of a point P arbitrarily, then we cannot find out. That's why we have developed this coordinate system XYZ here. But here also, instead of rotating our coordinate axis system B with respect to the coordinate system A through about a arbitrary vector, now what we can do is we will rotate this B stepwise about x-axis, y-axis, and then z-axis. We have x-axis, y-axis, z-axis attached to the frame here. So in a stepwise we rotate x about x-axis, y-axis, z-axis, so that finally it reaches the final position of the coordinate axis B here, and it will also rotate exactly the phi amount, the angle phi amount. So that's how we will do here in this one. And the angle rotated about these coordinate axis are called as the Euler angles. For example, here in this first case, this is the x-axis. I have considered this one, and this is a rotation about x-axis. So this is the x-axis. So whatever angles it's making is called as Euler angles here. So in this case, what I did is, this is the x, y, and z. This is the original coordinate system, and I rotated this coordinate system about the x-axis. How I rotated? This y and z are in the same plane, that is a yz plane, and I rotated this yz plane about this x-axis. And I always you should always remember that whenever we rotate, we always follow the right hand thumb rule. So here we are rotating from y to z. Why? Because the order is x, y, z, and then from z to x. So when I keep x as a constant, a fixed one, and rotating yz, this is rotating like this. So this is the x here. So when I rotated here like this, then this axis, y-axis, reached the new position y dash, and axis z is reached new position z dash. And we should remember that this y dash and the z dash in the same plane, that is a yz plane here. That means the whatever angle here turned by this yz is equivalent to the z axis here, z dash axis here, and that angle is alpha 1 in this case. And if you draw the angle between these two here in this diagram, these are the unit vectors. I is the unit vector along the x-axis, and I dash is the unit vector along the x dash. But here x and x dash are coincident. Why? Because we are rotating about the x-axis. And what is the angle between I and j? That is 90 degrees. And what is the angle between I and j dash here? That is also 90 degrees here. How? Because this is a plane, jk is the plane, or the yz is a plane, and x-axis is perpendicular to that plane. So if you take any line on that plane, that line also perpendicular to the x-axis here. And here j dash and k dash is nothing but lines on the plane jk in this diagram, or plane yz in this diagram. So that means I or I dash is perpendicular to j and as well as j dash In the same manner, I and I dash are again perpendicular to the k and the k dash here. We need to remember that. And what are the angles between these k and j? Here, angle between j and j dash is alpha 1 here. This is alpha 1. And what is the angle between j and k? That is 90. And j and k dash, this is alpha 1. So 90 plus alpha 1. This is the angle here. And then what is the angle between j dash and k? We need to subtract alpha 1 from the 90. So this is a 90 minus alpha. This is a 90 minus alpha. And then what is the angle between j dash and k dash? That is again 90 degrees. Why? Because whatever the amount of rotation it executed, j1 executed by j1, the same amount of rotation is executed by the k dash. So the angle between these two are 90 degrees here. So if I substitute these values in this our rotational equation, then what happens? So now I will write here. So r equal to here I dot I dash, that is a cos 0 degrees. So dot product is nothing but a cos angle between these two vectors. So cos of angle between these two vectors, here in this case 0 degrees. So this is a 1, cos 0 equal to 1. And angle between I and j dash is 90 degrees. So cos 90 is 0. And then here angle between I and k dash is again 90 degrees. So cos 90 is 0 here. And what is the angle between these two? Again 90 degrees. So here also 0. And what is the angle between this k and I dash? Again 90 degrees. So this is also 0. And now this one j and j dash. So what is the angle between j and j dash? This is j and this is j dash. So this is alpha 1. So here this is simply cos alpha 1. And what is the angle between j and k dash? This is the k and this is the k dash. That is a 90 plus alpha 1. So cos of 90 plus alpha 1, that is a minus sine alpha 1 here. And the angle between k and j dash, this is the k and this is the j dash, that is 90 minus alpha. So cos of 90 minus alpha is cos alpha 1 here. And angle between k and k dash, this is the k and this is the k dash, that is alpha 1 here. So again this is the, sorry, this is a 90 here in this case, this is a sine, because 90 minus alpha is a cos 90 minus alpha is a sine alpha. So sine alpha 1, and here we will get a cos alpha 1. So this is the rotational matrix. Whenever we execute a rotation about the x-axis, then this is the matrix that we need to use. So based on the given rotation, we need to substitute alpha 1 here, so that we will get the rotational matrix. In the same way, what is the rotation about the y-axis? So in the previous case, the first step is I rotated about the x-axis, and after that, now I will rotate about the y-axis here. So if I say, in the previous case where we stopped at the frame B1. This is the frame B1 X. This is the X dot. So X is at the frame B1, and now we reached frame B2. That means in the previous case from A to B, we rotated B1, and now from B1 to B2 we are rotating B1 from B1 to B2 here. And this is again right hand thumb rule. So when I fix Z, what are the order? So when I fix Y, what is the order now? So Z, and then it again start with the X as if in the cycle. So this should rotate from Z to X. So when I rotate from Z to X, then this is the Y. That's where it's pointing now. And when I rotate this, and this X and Z are in the same plane. And when the Z and X are in the same plane, and if I rotating about this one, then these new axis also in the same plane. That means these y dash and then as well as x dash are perpendicular to the y axis here. This is perpendicular and this is also perpendicular. Automatically this is also perpendicular. These two also perpendicular here. And if I draw in this manner by in the representation of the unit vector, then the angles between j and k is 90 degrees, and J and K dash also 90 degrees, because this is K dash in the same plane of the Ki, and Ki is a plane of Ki is perpendicular to J, so that K dash also perpendicular to the J as well as J dash, and J is perpendicular to I and as well as to the I dash here. And what is the angle between, K and K dash? That is alpha, and I dash also alpha, and the angle between K and I dash. So this is the K and I dash, this is the I dash, that is a 90 plus alpha 2 here. It's rotating alpha 2, so that's why it's a 90 plus alpha 2. And what is the angle between I and K dash? This is the 90 minus alpha here. Why? Because I here is rotated alpha 2 here. So again, if I substitute uh, in this rotational matrix, then this will become here from B1 to B2 here. So what is this value here? So here I dot I dash, the angle between I and I dash is a cos alpha 2. So this is a cos. I will write for cos C, and for the sine I will write S. So this is a cos alpha 2, and the angle between I and J dash. This is a J dash and I, that is a 90 degrees. So that is a 0. And the angle between I and K dash. So this is the I and this is the K dash, and the angle between these two is 90 minus alpha 2. So cos of 90 minus alpha 2 is sin alpha 2. And angle between J and I dash again is a 90 degrees, then its value is 0. And angle between J and J dash, so that is a 0, so it will become 1, cos 0 1. And angle between J and K dash again 0, it's 90 degrees, so its value is 0. And angle between K and I dash, this is the K and this is the I dash. What is this angle? This is a 90 plus alpha 2. So cos 90 plus alpha 2 is minus sin alpha 2 here. And again here angle between K and J dash is 90 degrees, so its value is 0. And the angle between K and K dash, again that's alpha 2. So this is a cos alpha 2. So this is the transformation matrix for when I rotate about the y-axis. Now I will rotate about the z-axis. So this is the z-axis, and I am rotating like this. Again, this is the right hand thumb rule. So from x to y, so that z is going up here. And here in this case, this x dash and as well as y dash in the same plane of xy. So that this x dash, y dash, all these four lines are perpendicular to the z and z dash. That means whenever we need to find out the angle between these combination of these, then this is 90 degrees. And again, if I substitute in this one, here I into I dash, this is the angle, that is alpha 3 here we have written, and I into J dash, this is the I, and this is the J dash. So this angle between these two is 90 plus alpha 3, so minus sin alpha 3. And I into K dash is 90 degrees, so that its value is 0. And these two angle between these J and I dash, this is the angle between these two, that is 90 minus alpha 3, so that's why sin alpha 3. And here J and J dash, this is the alpha 3 between J and J dash, so this is the one. And angle between J and K dash, so this is the K and K dash, and angle between these two is 0. And angle between K and K dash, that is a 0, so its value is 1 here. And again we will get here also 0 and here also 0. So by rotating about x-axis, y-axis and z-axis in the step manner, finally we reach the our frame B here. We reach the frame B here. So if I simply multiply these three rotational matrices, then I will get the total rotational matrix here. And we need to remember that this is a non-commutative. That means order of this one is very much important. So first, if I have to rotate about the x-axis, then I need to multiply in that order only. If order is missed, then we will get some other rotational matrix here. And here there are so many combinations. It's not only like always we need to first rotate about the x-axis and then y-axis and then z-axis. You can follow any order, but that order is in a such a way that finally we need to reach the desired rotational matrix or the desired frame, a rotational frame. So that's why this is a non-commutative, and whenever it's a non-commutative, there are so many different combinations are possible. For example, initially I can start with the x, y, and then z, and again I can go like this x, z, y, because this order is important, and I can go like this, x, x, y, and x, z, z, and then x, y, y. So there are so many combinations like this. We can go in so many combinations.